third way that you can find the turning point is by using completing the square. Basically, if you put the equation in the form ax plus p squared plus q, the turning point will be equal to minus p q, where the x coordinate is minus p and the y coordinate is q. You don't need to know why this is, but just briefly, if you look at a quadratic, you'll find that all values of y actually have two corresponding values of x that can give them. The reason this is because if you look at the completed square form, the reason this is because is for this part here there are two values that can give each value of x plus p squared, and that's due to the fact that the square root of x plus p squared is equal to plus or minus x plus p. There is only one value of x plus p squared in which it only has one corresponding value of x that can give it, and that is when x plus p squared is equal to 0, because if you square root that, you're just square rooting 0, which is obviously just equal to 0, and you don't have plus or minus 0, so you only have one value. So therefore you know that the only value of y where there is only one value of x that gives it is when x plus p is equal to 0, and therefore x is equal to minus p, and the one value of y that only has one value of x corresponding to it is the turning point if you actually look at the graph. And then from that you can say that y is equal to a x plus p squared plus q, but as x plus p squared is equal to 0, this whole bit cancels out, so then y is just equal to q. So then you can get that the turning point is equal to minus pq. You don't have to remember what I just said, you don't need to even understand it. I just find that when I'm trying to remember something, it's useful for me to have the explanation, because then it helps me remember stuff more. But if you want to, you can just remember this rule here, and yeah, that's the only thing that you need to know. So for this example, y equals 2x squared minus 6x minus a, we need to put it in the completed square form. So the first step, remember, is to factor out 2 or a. So you would do y is equal to 2x squared minus 3x minus 8. Remember that 8 will remain on the outside. And then the second step is to use the tip, in which you do x minus 3 over 2 squared minus 9 over 4. But remember, all of that will be in the 2. Then the minus 8 will be on the outside, and then that's obviously all equal to y. And then the third step is just to expand it all out. You can say that y is equal to 2x minus 3 over 2 squared minus 9 over 2 minus 8. And if you simplify that, you'll find that 2x minus 3 over 2 squared minus 25 over 2. So therefore, you can get it in the form a x plus p squared plus q, and you'll find that the turning point will be minus p, so it will be 3 over 2 q, which will be minus 25 over 2. Remember, it's going to be minus p, so it's going to be the minus of minus 3 over 2, which will be the positive 3 over 2, and then it will just be minus 25 over 2 for the y value. Really quick, I have seen before questions ask for the minimum / maximum value of a quadratic. It will ask for the minimum or the maximum depending on if it's a positive or negative parabola. This is just the same as finding the y-coordinate of the turning point. So for example, a question could ask, find the minimum value of 2x squared minus 6x minus 8. We'll just use the same quadratic as you're already using to save time. Well, if you think about this, the minimum value will just be this, which is the turning point. So what you do in this question is you're going to find the turning point, which we've already found is 3 over 2 minus 25 over 2, and then you're just going to find the y coordinate of it, which is minus 25 over 2, and that's the minimum value. The x value isn't important. It would be important if they said find the value of x for which this minimum value exists, in which case you would say that it would be 3 over 2, but the minimum value itself for this quadratic will be minus 25 over 2, as this is the lowest point that the quadratic will reach here. If it's a negative parabola, so if it's, let's say it's minus 2x squared minus 6x minus 8, then it will ask you for the maximum value instead, in which case again you just find the turning point should be the maximum value. Really quick as well, you might question what happens if they want to find the maximum value of 2x squared minus 6x minus 8. What happens if they want to find the maximum value of this quadratic here? Well, if you think about it, there is no maximum value of this quadratic because it goes on forever. So they're never going to ask that. They're never going to ask you to find the maximum of a positive parabola or the minimum of a negative parabola because it doesn't exist. Okay, so now we have everything we need to sketch the graph. So whenever I'm sketching a graph, there are kind of 4 tick boxes that I want to get off. Remember, you don't have to do the graph exactly, but these 4 things you want to get off. First of all, is it a positive or a negative parabola? And in this example, it's going to be a positive one because the coefficient of x squared is positive. Secondly, the roots. Now, the thing that is important about the roots, there are 2 things really. One, you need to make sure that you get the positives and negatives right. So one of the roots is positive and one of the roots is negative. So you need to make sure that on your graph, one of the roots is positive and one of the roots is negative. Secondly, because on the x-axis you have 2 points, that you're going to be plotting, they need to be somewhat in a scale to each other. So for example, if you put the minus 1 here, the root, and you put the 4 here, obviously that doesn't really make any sense. So you need to do a tiny bit of a scale in terms of when you're doing it. So let's just try and aim for, this isn't precise, let's just try and aim for the minus 1 root being here and the 4 root being here, let's say. Third of all, we need to do the y-intercept. The scale doesn't matter as the y-axis and x-axis scale is different, so I'm just going to aim for about here for the minus 8. It doesn't matter, even though the minus 1 and the minus 8 are quite near each other in terms of magnitude. It doesn't matter because the y-axis and x-axis scale are different. And then finally, you're going to want to get the turning point. Now, the turning point, you want to get this in the right quadrant. The quadrant is you have the 4 quadrants, one here, one here, one here, and one here. And you want to get it in the right quadrant because then that makes sense in terms of its signs. So the turning point has a positive x coordinate and a negative y coordinate, so it's going to be in this quadrant here. Okay, so now we can plot our graph. Now, because I'm doing this on a drawing tablet, this might not be the most precise thing in the world, but I'll try my best. So I'm going to do it like this, and that's okay. That's a pretty okay quadratic. I might rub that out because that's a tiny bit bent, and put that in. But the important thing you need to do is you need to label your points. So this here is minus 1, this here is 4, this here is minus 8, and the turning point, which is about here, is 3 over 2 minus 25 over 2. So the most important thing that you need to do is label where the coordinate axis is, where it intercepts the coordinate axis if it asks, and if it asks, label the turning point. Okay, so here's a question on quadratic graphs, so pause the video, have a go, and I'll go through the answer in about 5 seconds. Okay, so when it's saying y is equal to f of x, hopefully that's clear of what that's saying. It just means that y is equal to minus x squared plus 4x minus 4, and it just wants you to sketch that graph. So the first thing you need to find is the roots, and the easiest way to do that is just put minus x squared plus 4x minus 4 equals 0 into the equation part of the calculator, and once you do that you find that there is one root, which is x is equal to 2. The second thing that you need to do is find the y-intercept. Again, this is even easier because all that is the final number, so the y-intercept is going to equal minus 4. The third point that you need to find is the turning point, and this is a bit interesting because you notice that we only have one root, or equal roots if you like. If you actually draw the graph of a quadratic that only has one root, you will actually find that the turning point is actually the root, is actually the point at the root. So we can say that the turning point is the root, which is going to be 2, 0. So now we have everything that we need in order to sketch it. So I'm going to do the 4 bullet points from before as well. Is it a positive or a negative parabola? Well, it's going to be a negative one because the coefficient of x squared is -1. Then we need to do the root, or in this case just the root. So it's positive, so we'll just say it's around about here. We need to do the y-intercept, which is going to be negative, so we'll say it's around about here. And the turning point, well, this is easy because the turning point is just going to be the root, so we don't even really need to worry about that. We just need to remember to label it. So if we draw the quadratic, we can say that it looks something like this, where it touches the x-axis here, intercepts the y-axis at -4. Remember, it's really important to label it. And then the root is at 2, and the turning point is 2, 0.